discuss about quadrilaterals. Quadra means 4. Tetra also means 4. Tri means 3. Bi or di means 2. Di, tri, tetra, penta, hexa, hepta, like that. Quadrilateral. Lateral means sided. A 4-sided figures in geometry. As we have learned, triangles, 3-angled figure, closed figure, triangle. As 3 points are always coplanar, and if they are not collinear, we join these 3 points by line segments and get a triangle called, we call it triangle. It is always coplanar. Now, further, if there are 4 points, then we can have a 4-sided figure. In our life, we find 4-sided things in many places: tables, chairs, boxes, rooms, mobiles, many things. 4-sided TV screen. So, what is a quadrilateral in geometry? A quadrilateral is union set of points joining 4 coplanar different points, of which no any 3 are collinear, is called a quadrilateral. What are the conditions for a figure to be quadrilateral? Here we have, first condition is 4 points, different points, and we have to join these points by line segments. Second condition is that out of which no 3 should be collinear. Suppose we have coplanar points like this, 1, 2, 3 and 4. But out of these 4 points, if 3 are collinear, then joining them, we cannot have quadrilateral. Moreover, if 4 points are there, 1, 2, 3, and the 4th point here somewhere out of the plane, then also joining them, this point is out of the plane here, this also being a figure of 4 different points, but all these 4 points are not collinear, we cannot call this figure as quadrilateral in geometry. The definition for quadrilateral in geometry that there should be 4 different points. Out of these 4 points, no 3 should be, any 3 should be collinear, and all these 4 points should be coplanar. They should occur in a plane only, and you join them by line segments, we get a quadrilateral. Thus, a quadrilateral is a closed figure. It divides this plane in 3 parts: interior of the quadrilateral, exterior of the quadrilateral, and the points of the quadrilateral itself. These points are called vertices of the quadrilateral. A, B, C and D, and all the points of line segment AB, point B, point C, and all the points of line segment BC, point C, point D, and all the points of line segment CD, point A, point D, and all the points of line segment AD are united together, union set makes quadrilateral ABCD. Thus, quadrilateral is a four-sided figure. It is a coplanar figure. It has four vertices and four sides. Now, suppose we have 4 points like this: P, Q, R, PQ, R and S. Here also we have 4 points. Point P, point Q, point R and point S. The condition 4 is satisfied. All these points P, Q, R, S are coplanar. This condition is also satisfied. They are different. This condition is also satisfied. Points of which not any three are coordinate. This condition is also satisfied. Can we call this type of figure a quadrilateral? Consider it has 4 vertices: vertex P, vertex Q, vertex R and vertex S. Does it have 4 sides? Side PQ, side QR, side RS and side PS. Is it coplanar figure? Yes. Does it divide this plane into interior and exterior? Yes. Can we call this quadrilateral? What can be the answer? Yes, it is also a quadrilateral. Quadrilateral is called lateral mid-sided figure. But can you mark the difference between these two figures? Yes. This figure is different from this figure. Here you join the opposite vertices. Both these line segments, except the endpoints, lie in the interior of the quadrilateral. This line segment we call it diagonal of the quadrilateral, and endpoint A and endpoint C. And all other points are in the interior of this quadrilateral. Here, diagonal PT and endpoint B, endpoint D. All the points are in the interior of the quadrilateral ABCD. Thus, both these diagonals have all points except endpoints in the interior of the quadrilateral. What is the case here? Here we have opposite points diagonal PS, endpoint Q, endpoint S, and all the points. Yes, they are in the interior of the quadrilateral. But what about the other diagonal? The other diagonal PR, endpoint P and endpoint R lie on the quadrilateral PQRS, but all other points of this diagonal lie in the exterior of the quadrilateral PQRS and not in the interior of the quadrilateral. So this is not a quadrilateral of this type. This quadrilateral type we call it convex quadrilateral, and this is non-convex quadrilateral. We are concerned with convex type of quadrilaterals only. We are not to consider anything about such a non-convex type of quadrilateral now at the moment, presently. Therefore, we simply have to take a distinguishing factor that there also exists a quadrilateral which is not of convex type. We call it non-convex quadrilateral. Now, any figure to be convex set of points or non-convex set of points, there is one condition only to be satisfied. What is the condition? You take any 2 points of the interior of the figure. The closed figure always divides the plane into interior and exterior and the points of the figure itself. Now, if you take any 2 different points of the interior of the figure, join them, and if the line segment joining these 2 points completely lies in the interior of that figure, the figure is said to be convex type. Any 2 points you can select. Whereas here in this case, if we select 2 such points like this, perhaps it may so happen that the line segment lies in the interior, but you are at your liberty to select any 2 points. Suppose you select this point and this point here and join this point. You find that all the points of this line segment do not lie in the interior. Some points of this line segment fall in the exterior of this figure. So this is a non-convex figure, this is the convex figure. This is the convex type of quadrilateral. Now onward we will be discussing about convex type of quadrilaterals only in our course. So what are the various convex type of quadrilaterals or quadrilaterals in general science in our course? So types of quadrilaterals. Before discussing the types of the quadrilaterals, let us check one point. A quadrilateral is a figure of 4 sides, 4 vertices, A, B, C, D. It makes 4 angles. It is a convex type of figure. Now, what will be the sum of all these 4 angles? As in case of triangle, we have learned that the sum of all 3 angles of a triangle add up to 180. What is the case with quadrilateral? Now here there is a very simple method of getting the result. We join 2 opposite points. This is called diagonal of the sine quadrilateral. A quadrilateral has got 2 diagonals. Take any 2 opposite points and join them. We see that the quadrilateral is divided into 2 triangles. Now, sum of points of one triangle, this angle, this angle, this angle. Sum of measures of angles of this triangle add up to 180, we very well know. Similarly, the sum of the measures of this triangle, this angle, and sum of the angles of this triangle also add up to 180 degrees. And here at point B, see, we have angle ABD and angle BBC. Both these angles have common vertex, common arc BD, and the interiors are different, so they are adjacent angles. So the measure of this angle ABD plus measure of angle BBC will be equal to measure of angle ABC. So measure of this angle ABC plus measure of angle ABC plus measure of angle A plus measure of angle C will be 180 plus 180. That makes 360. So measure of all angles of a quadrilateral is take first type, square. If four angles of a quadrilateral are same, equal in measure, each, and all four sides are equal, then the figure is said to be a square. When four angles are equal, each will be 360 divided by 4. All sides of equal length the given quadrilateral is a square. For quadrilateral to be a square, each angle should be of 90 degrees. And all sides equal. Second one, rectangle. Let us make here a small figure of square. All four sides equal. We have all four sides equal. All angles of 90 degree. Rectangle. When every angle, every or each angle of a quadrilateral is of 90 degrees and opposite sides equal in length, which is called rectangle. We have the figure. All four angles, each of them 90 degrees. This is the side for 90 degrees, and opposite sides equal in length. The quadrilateral we get is called rectangle. So, dear students, try to learn this, and the remaining we shall discuss in the next.